Hi dear students, and welcome back to this presentation where we'll be looking at 2025 Northwest Regional Mock and propose the solutions to Pure Mathematics Paper 2. In the previous videos, we proposed solutions to question 1 and question 2. So if you haven't watched those videos yet, go back to my channel and watch them before you return to this one. So today we are going to propose the solution for question 3. And the question is based on logic and logarithm. And the first part of the question, we are asked to construct a truth table for this complex statement. So I have a complex statement to propose the truth table for that. So in order to do that, I have to decompose this compound or this complex statement into simpler statements, obtain their truth values, and combine them as is to obtain the truth table for the entire statement. So first things first, I need to create a table for P and Q. And these are the truth values for P and Q. Then I move on now. The next statement I need to look at is the statement not Q, which is a negation of Q. Negation of Q just means I'll change the truth values of Q. Wherever I see true, it becomes false, and where I see false, it becomes true. So I'll be having not Q. Here Q is true, so not Q is false. Here Q is false, not Q is true, right to the end. So I've proposed the truth table for not Q. Then next, I need to find the truth table for this compound statement. That is the disjunction between P and not Q. And the disjunction between two statements is false only when both statements are false and true in all the other cases. So I need to create a table for that. For P, here is P and not Q. So this statement will only be false when both of the statements are false in this case and true in all the other cases. That is why I've got a false here, and here I've got a true, and a true, because we have at least a true on that row. Now finally, I need to find the disjunction between the conjunction between these two statements, the conjunction. So that is what this symbol stands, the conjunction between these two statements. And the conjunction between two statements is true only when both statements are true and false in all the other cases. So I create a column for that. I am looking at P or not Q, and I'm looking at Q. So I'm looking at these two tables here. So I'm looking, and I said that the statement is true only when both arms are true. Here is true and here is true. That's why we have a true. And then we are going to have false in all the other cases because I have at least a false in that arm. So I hope you have understood this particular question. But if you do have any questions, please just leave it in the comment section. I'm going to respond to your question as soon as I can. So let's return back and move on to the Roman 2 part of the question. And we were asked to show that log to the base 16 of xy is equivalent to half log to the base 4 of x plus half log to the base 4 of y. In order to proceed, there are some laws of logarithm that we need to be aware of. So let's get some definitions. So the first definition is that log to the base b raised power n. So b to power n is the base of that log of a raised power n. This n, of course, becomes a coefficient, and n, which is the exponent of the base, becomes the denominator of the coefficient of that log. Or in simple terms, log to the base b raised power n of a is equals to this n, which is the exponent, reciprocate and becomes the coefficient of that logarithm. All right. So first things first, let us take the left hand side, which is log to the base 16 of xy, and split it into 2 because we have a law of logarithm. Look at property 5 that states that log to a base e of ab is equals to log to that base, which is e of a, plus log to that base e of b. So I have to separate this by adding them. So that is what I have done here. So the next thing to do is that I'm going to write 16 as powers of 4. And so I have 16 as 4 squared, I have 4 squared. Then I come back and I apply this law very fast, and I'm going to be having that this 2 is going to reciprocate and becomes the coefficient of this log. So I just have half log to the base 4 of x plus half log to the base 4 of y. So you can just take a a screenshot of these properties, and then at your spare time, you go through the laws of log. This is the law of log that we just used. It is property number 7. Log to the base b of m. Log to the base bm of a is equal to 1 over m, 1 over that exponent of the base, log to the base b of a. All right, let's just return back. So the b part of the question, we were asked now that hence, so we use the knowledge of the a part or the first part and solve this pair of simultaneous linear equations. So I'm going to write both equations. This is the first equation and this is the second equation. But from the previous part, we had shown that log to the base 16 of xy can be expressed like this. So I will just replace log to the base 16 of xy by this expression, and so I'll be having half log to the base 4 of x plus half log to the base 4 of y is 3 divided by 2, and this equation remains as is. So what I can do next is that I can cancel out these denominators by multiplying each term by 2. So let me multiply each term by 2. So this 2 cancels out, and I'm left with this very nice equation. So I can call it equation 1, and equation 2 I'll just leave it as it is. I'll call this equation 2. Now this term log to the base 4 of x and log to the base 4 of x are the same. So if I subtract both equations, equation 1 minus equation 2, that is, if I subtract equation 2 from equation 1, these terms are like terms and they will disappear. So let me do the subtracting, and I will have that this term has vanished, and so I'll be having log to the base 4 of y minus negative 2 log to the base 4 of y is equals to 3 minus 0, which is 3. Now this just changes to positive, and I'm adding 2 like terms. 1 of this log plus 2 of this log gives 3 of that log. So I just have this, and I can do well to divide both sides by 3, and the 3 cancels out, and I have log to the base 4 of y is equals to 1. Now to proceed, let us try another definition that will help us to change from logarithm to indices, and the definition is that if I have log to the base a of b, which gives me c, then the base of the log remains the base of the logarithm or the base of the index. The answer becomes the exponent, and this value becomes the result. So I'm going to convert this and proceed to solve. So when I convert, I will have 4 raised to the power 1 is equals to y, and 4 raised to the power 1 gives us 4, so the value of y is equals to 4. I can just take y as 4 and I substitute it into equation 2. So I'm going to replace here by 4. So let us move on. So when I substitute, I'll be having log to the base 4 of x equals to 2 into 1, because it's equals to 2 into 1. Because when I substitute, this is what I get, because I'm going to take 4 and I substitute here into this equation, and then I have that log to the base 4 of 4 will give me 1. That is why I have 2 into 1. So I have negative 2 log to the base 4 of 4, because that is the value of y. And then we know by definition that when the base is the same as the value, the answer gives me 1. So all of this is going to boil down to 1, and I'll be having log to the base 4 of x minus 2 into 1 equals to 0. I send this negative 2 the other way, and I have log base 4 of x equals to 2. And again, I'm going to change these two indices, and I'm going to be having 4 raised to the power 2 is equals to x, and so that gives me x as 16. So we have come to the end of this particular question, but if you do have any questions, please leave them in the comment section below. And if you watch this video and find value in the content, please give me a like on this video, subscribe to the channel if you haven't already, and turn on the bell icon to keep notified when I post new videos. Thank you, and I will see you in the next one.